Welcome back, guys. We're going to be going back to 2-5, day 1, and in this lesson we're going to be talking about axioms and postulates having to do with geometric terms. So a postulate is, or an axiom, sometimes it's called, most often called a postulate, is a statement that is accepted as true without proof. Basic ideas about points, lines, and planes can be stated as postulates. And then I'm going to go over them. You can go ahead and sketch out the example. So the following things are some postulates that are true about lines, planes, and points. So I mentioned earlier in the year that this is one that you'd have to know. Through any 2 points, there's exactly one line. So here we have line N or line PR. So in verbal language, line N is the only line through points P. So the next axiom has to do with planes. So through any 3 non-collinear points, there's exactly one plane, and plane K is the only plane through non-collinear points A. Next one is a line. A line contains at least 2 points, and we can see that we can either talk about QR or PQ or PR. The next one is a plane contains at least 3 non-collinear points, and we talked about this one earlier in the year as well. Here it says if 2 lines intersect, then their intersection is at exactly 1 point. So you can go ahead and sketch out some of those ideas. Press pause if you need to. Sorry, if 2 planes intersect, then they intersect at a line. So we also had problems like this before where we have kind of like the doors at Cashwise. They intersect at this middle section, which is actually a geometric term for a line. And we have midpoint theorem, which says that if we have this section AB and we have these markings, a little pink mark, that the 2 smaller segments are congruent. Alright, so we have some examples. It says, explain how the picture illustrates the statement is true, then state the postulate that can be used to show the statement is true. So in the first example, we want to just look at points F and G, and it says points F and G lie in plane Q and on line M. Line M entirely lies in plane Q. So there's a postulate on the previous page that said if 2 points lie in the same plane, then the entire line containing those points also lies in the plane. The next one, B, points A and C determine a line, and it is true through any 2 points there's exactly one line. Next we have another picture here. It says plane P, so we're looking at this side over here. Contains E, B, and G, and then the postulate is a plane contains at least 3 non-collinear points. And then the next one, lines AB and BC intersect at point B, and the postulate is if 2 lines intersect, then the intersection is exactly 1 point. So we're going to be looking at some postulates here, again, trying to figure out which postulate we're going to be using. So here it says if plane T contains 2 lines, EF, and EF contains point G, then plane T contains point G. So for this one, if 2 points lie in the same line, then the entire line lies in I'm going to read that again. If 2 points lay in the same plane, then the entire line containing those points lies in the plane. So the next one, EF, contains 3 non-collinear points. EF contains 3 non-collinear points. That's not true because if they're collinear, it means they would have to lie on the same line. So next one, I want you to try this one. Press pause. It says plane A and plane B intersect at a point. That is false because 2 planes intersect at a line. Our next one, point N lies in the plane and point R lies in the plane Z, then you can draw one line that contains both points R and N. So that is actually positively true, because if we have a couple of planes here, and let's say here we have plane X, and then we have point N, and let's say we have another plane down here, this is called, oops, get rid of this, and we have this other plane Z, and it contains this point R. The only way that the only possible lines that you could draw is one line through those two exact points. The end of this lesson today is just going to be practicing on some of the vocabulary, and then we'll get into the paragraph proofs next time.